welcome back. All right, so make sure you have your toolkit out and you're ready to take notes. All right, so the past 2 days we've been talking about interest, simple interest and compound interest. When we did compound interest, it involved an equation with exponents. So let's dive a little deeper into exponents. Today we're going to talk about, let's write down exponents. And we're talking about multiplying and dividing them today. Okay? So, first let's just remember how an exponent works. So if I said 2 to the third, what I mean is 2 times 2 times 2. We know that. If I said like x to the fifth, what I mean is x times x times x times x times x, right? Okay. So when we have two numbers that have exponents, it works essentially the same way. So for example, if I had 5 to the fifth and I were multiplying it by 5 squared, I would break down 5 to the fifth, which is 5 times 5 times 5 times 5 times 5, and break down 5 squared. We're going to multiply that by 5 squared, which is 5 times 5. So in reality, we're multiplying 5 together 7 times, so it's really 5 to the 7th. Okay? And the same works if you had a base that was an x. Oh, you know what? Let's talk about that real quick. This larger number, it's called the base. We already know this small number is called the exponent, right? Okay. So anyway, if we break that down, we've got x times x times x, that's x to the third. Then we're doing x times x times x times x times x for x to the fifth, for a total of x to the eighth. All right? So let's jot down a quick note about that. Well, you know what? Yeah, let's jot down a quick note about that. So let's look at the pattern here. So if you look back at these two, we did 5 to the fifth and 5 squared. Well, 5 plus 2 is 7. Look at that. Here we did x to the third times x to the fifth. Well, 3 plus 5 is 8. Look at that. We found a pattern. Okay. So maybe kind of near the bottom of your page, we'll gather all the patterns that we're finding. So we're going to find a few more patterns today. So maybe label that patterns, like near the bottom of your page. So we'll do a few more examples and then we'll kind of gather up all of our patterns. So one of them is when you are multiplying, oh geez, there we go. Multiplying, oh, okay, I changed colors. Bases, you add the exponents. So, for example, x to the third times x to the fifth is the same as x to the 3 plus 5, which is x to the 8th. Okay? So we'll keep that slide for our patterns that we find. All right. So let's talk about another instance of multiplying exponents. So another example would be if we had 5 to the fifth, but then we took an exponent of that, so 5 to the fifth squared. So let's break down what this means. We want 5 to the fifth multiplied by 5 to the fifth. You with me there, or is that confusing? Let's talk about that. So if I had x squared, I would mean x times x, right? Here we have 5 to the fifth squared, so I mean 5 to the fifth times 5 to the fifth. And if we break that down further, we know from the previous slide, which is what we've been doing all along, that's 5 times 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 5. You with me? So we end up with 5 to the 10th. 5 times 5 times 5, 10 times over. Okay. The same works, again, with variables. So if I had, for example, x to the third, and then we took that to the third power. What I want is x to the third times x to the third times x to the third. And then we break that all down. X times x times x, that's this one, times x times x times x, that's this one, times x times x times x, that's this one. We've done that a total of 9 times. So if we look for the pattern, we'll notice that 5 times 2 is 10. We'll notice that 3 times 3 is 9. So there's our pattern. Let's add that to our list of patterns. So what we want to say is, when you take the exponent of an exponent, you multiply the exponents. Now, these only work if the bases are the same, but we'll be practicing that in class tomorrow. So anyway, exponent of exponent, we multiply the exponent. So an example of that would be x to the third, taking that to the 5th power. So that's the same as x to the 3 times 5, which is x to the 15th. These are just kind of shortcuts. All right, the next thing we're going to talk about is dividing exponents. There we go. So if I want to divide some exponents, like 2 to the 4th divided by 2 squared, expand it the same way we have been, but we'll just expand separately on the top and the bottom. So 2 to the 4th is 2 times 2 times 2 times 2. 2 squared is 2 times 2. Now, 2 divided by 2 equals 1. And when you multiply 1 by something, it's just itself. So essentially these cancel out, because multiplying by 1 cancels out. 2 over 2 is 1. It cancels out, which leaves you with 2 times 2, which is 2 squared. And on the bottom, we've canceled out to 1. So that equals 2 squared. Okay? Let's try that again with variables. So example, if we had y to the 7th over y to the 4th, the top would be y times y. We're going to do that 7 times. 4, 5, 6, 7. The bottom would be y times itself 4 times. And we're canceling out when we have the same y on the top and bottom, which leaves us with y to the 3rd on the top, because we've got 3 y's up here, and we've canceled to only 1 left on the bottom. So our answer is y to the 3rd. So let's look for our pattern. Well, 4 minus 2 is 2. 7 minus 4 is 3. So that's our pattern. Now our pattern's slide got full, so I'll just write it over here. So our last pattern, write this down at the bottom with your list of patterns, is when you divide exponents, subtract the exponents. Okay, so our example would be x to the 5th over x to the 3rd is the same as x to the 5 minus 3, which is x squared. So if you're dividing two things, you subtract their exponents. So that is everything we need to know about exponents. Make sure that you have that all copied down in your toolkit and that you answer the questions here.